Logistic growth. Yesterday we talked about exponential growth and unlimited growth and how that doesn't occur in nature for very long. Limited growth is going to be much more realistic because as your population densities increase, each individual has less and less resources available to them. So it's going to be harder to survive, and your population size is going to level out. Carrying capacity is the maximum population size that any particular environment can sustain. Anything can be limiting factors, and we'll talk more about this tomorrow in class. But energy, shelter, refuge from predators, that should be predators. Nutrients available, water available, and suitable nesting sites. The per capita rate of increase is going to approach 0 as you approach the carrying capacity. And then you can see lots of critters will show this well in a lab setting. And you have predators lacking, which isn't real for the real world, but you can have things like bacteria, yeast, paramecium. This is a picture of paramecium. Some crustaceans and beetles will fit this model. We have two basic assumptions. One is that the carrying capacity is going to adapt instantaneously to growth, and then it's going to approach that carrying capacity smoothly. A lot of times it's going to go over or below, but the carrying capacity is like the average. If you look back, Daphnia, I'm going to go backwards. This is Daphnia, and you can see that it overshot a little and then comes back. Assumption number 2 is that regardless of population density, each individual added to a population has the same negative effect on the population growth rate. But we have something called the Ali effect, named after Dr. Ali. And this is where some individuals will have more difficult time surviving or reproducing if the population size is too small. The example in the book is if you have a little flower or plant. If you have a plant in a very windy area, it's not going to survive as well as it would if there were lots of other plants helping to block that wind. Again, reasons I'm not your art teacher. The logistic model is the starting point for thinking about how populations grow and constructing more complex models. And important in conservation bio, when you look at how predation affects a population, especially in populations that have been reduced to very small sizes. Estimating sustainable harvest rates for wildlife population, like hunting deer or even commercial fishing. And then estimating critical size below which an organism may become extinct. Example, here's the white rhino. Alright, so you can watch this on your own later if I went too fast, as I'm sure I did. But for now, sorry that's so bright. See you tomorrow.